Hey guys, Captain again. Today we are doing race day in our problem solving methods. We are going to be in a car racing a Porsche, and we're going to see a couple things using our kinematic equations. We're going to see who's going to win a race. Bet you since they're in a Porsche we probably don't have much hope, but we'll go from there. Okay? Just like always, the question can be seen below this video if you can't see it on here very well. But we'll get going. Today we are going to do things a little different. Usually after we set up our problem, do our picture, all that kind of stuff, we usually do one part at a time, work our way through it. But because of the way this problem works, we're actually going to end up doing parts 1 and 2 together. So when I read through it, I'm going to read through part 1 and 2 before we move on to 3. Okay? So we're driving our car towards an intersection, and we have a Porsche stopped at a red light. We're going 40 kilometers an hour, which is 11.11 about meters per second. When we get 15 meters from the light turns green and the Porsche takes off. It's accelerating from rest to at 3 meters per second squared continually with acceleration. We continue at our same speed at our 11.11 meters per second. And part 1 is to know how far from the stoplight do we pass the Porsche and what time it is. And then part 2 says at what point does the Porsche catch back up to us and how far away from the stoplight is it. So normally we don't do 2 parts at once, but it's going to work out a lot easier this way. So we're going to go ahead and work on part 1 and 2 before we go to the next one. Okay? So just like we always do, we're going to start with a picture. This picture is going to take most of a piece of paper just to do it well. So here's our little stoplight. Again, I'm not an artist, but we care basically once it turns green, that's what we're worried about. The Porsche is sitting there at the stoplight, which we will call initial position of 0. It's sitting at the stoplight waiting to go, and we know its initial velocity is 0 because it's not moving, but it has an acceleration of 3 meters per second squared. We don't know its final velocity. We have no idea. We don't know how long it's going to take for stuff to catch up. That's stuff we might need to find. Okay? Our car, which for me is going to be a Civic because that's what I'm driving, is way over here. And we're initially moving, and our final and initial velocity is the same, of 11.11 meters per second, because we have no acceleration. And again, we don't know time, but we know our times are going to match up. These times are going to be the same. Okay? So what we're trying to find is sometime in the future, we're going to be over here, and the Porsche and us are going to be in the same spot as we're passing the Porsche. We're still going at our same speed. The Porsche is still accelerating at its same acceleration, but we don't know its speed. We don't know what that time is, but we're going to look for that time. Okay. Even more in the future, the Porsche catches back up to us. Again, we needed to figure out what the time for that is. And so, again, there's sort of the basic idea of what the problem is. Okay. Now, if we look at our kinematic equations, which we've used before, one of these we know everything we need, the rest of them we don't. Well, we don't know final velocity for the Porsche at all, so anything with final velocity we can't use right now. So this half is gone. We don't know, final velocity there either. We can't use that, so it looks like we're down to one equation. However, there's a little trick to this equation. Let me write it down real quick. Get our picture out of the way as well. Our initial, or with this equation, the issue we have is our starting points. They're at 0 meters. We are actually starting at negative 15 meters because we are 15 meters behind the stoplight, if we're considering the stoplight 0. So we have to add that into this kinematic equation. We're just going to add a x naught, or an original position for each one of them. Okay. So again, our Porsche, I believe, was purple, so we're going to do all the stuff for Porsche in purple, and the Civic was in blue. So we're going to do all this stuff for the Civic in blue just to sort of keep it separated a little bit easier. Okay. So again, we set up our equation for our Porsche, and we know that our distance is our initial position plus initial velocity times time plus 1/2 of our acceleration times time squared. Now again, exact same idea for the Civic, or for our car. Exact same equation, but we have to keep them separate. So okay, so now we can start trying to figure out what we can use and what we can't use. Now, if we're looking at the Porsche, so our displacement, or its initial position is 0, right? So that goes away because it's starting at the stoplight. Our initial velocity, well, it's not moving, so that's 0. So what are we left with? 1/2 of the acceleration times time squared. So that's our equation to find the displacement of the Porsche as time goes by. We have the same idea for the Civic. Well, our initial position isn't 0 because we're 15 meters behind the stoplight, so that's where that negative comes in because we're behind the starting point. Well, our initial velocity is the same as our final velocity, but that's that 11.11 meters per second squared. And then again, we need time. Then we have 1/2 AT squared, but our acceleration is 0, so all that goes to 0. Okay. So if we plug in all the numbers here, I'll go back over here. Well, 1/2 of our acceleration, well, we knew that the car was accelerating at, where was it? Three meters per second squared, sorry. So 3 meters per second squared times t squared. Well, that gives us 1.5 meters per second squared times t squared. So that's our equation for our Porsche. And the equation for the Civic, we just bring down, because we already plugged everything in, negative 15 meters plus 11.11 meters per second times time. Again, time is going to be in seconds. So, we sort of got it set up. Now all we have to do, we know when they meet that the distance from here to here has to be equal. So if our distances are equal, these have to be equal to each other, so we just literally set the two things equal to each other. So d, our displacement, equals our displacement of our Civic. We actually plug in the numbers, we get 1.5 meters per second squared times t squared, and then we set that equal to negative 15 meters plus 11.11 meters per second. Again, just bringing it all down, times t. Okay. Now, if you look at this, we have a quadratic equation. So we're going to actually use the quadratic formula. So we need to get everything equal to 0. So I'm just going to bring all of this to the other side. So we're going to be with 1.5 meters per second squared times t squared. And then we'll do minus 11.11 meters per second times t, and then minus 15 meters. And then all that is equal to 0. Okay. So again, quadratic formula. I'm hoping you guys have seen that before, but we will plug it all in. So we're going to get t, because that's what we're looking for, is equal to negative b, or negative of a negative is positive 1.11 meters per second, plus or minus the square root of that squared, negative 11.11 meters per second quantity squared, minus 4 times 1.5 meters per second squared, times 15 meters, all over 2 times what's in front of there, 1.5 meters per second squared. Okay. So if we do that, and we actually go through all the math, plug into the calculator. I'm not going to show you guys that part because I have faith you can do that. We get time equals two things, either 1.78 seconds and, I guess, technically, because it's both of them, 5.63 seconds. Now, the reason why we did part 1 and 2 together, well, the first time we meet is, the time for when we first catch up. The second time is for when they catch up to us. So we've already gotten both times, we just need to find the displacements for both of them. Now, that being said, if we look at our original equations up here, we can plug these numbers into either one of them to find that distances. So let me scoot this up and we'll write our times down again. So our 2 times are 1.78 seconds, which is when we catch the Porsche, and 5.63 seconds when the Porsche catches us again. Okay, so those are our 2 times, and we need just to find the distance that is. Okay, again, it doesn't really matter which equation we use, so we're going to go with plugging in the 1.8 or 1.78 seconds into our x equals 1/2 at squared equation. So again, we plug that in. Well, we 1/2 our acceleration of our Porsche. We're doing our Porsche right now. Again, still at 3 meters per second squared. Now we have 1.78 seconds. We have to square it. That gives us a position of about 4.75 meters. So that's 4.75 meters at 1.78 seconds. So that is actually the answer to part 1. 1.78 seconds after the green light, we meet them at 4.75 meters past the green light. We'll do the exact same thing, use the exact same equation to do part 2. So this is going to be part 2. Same equation, it doesn't matter which one we use, we'll use a simpler one if we can. So we're going to plug it in, we're going to 1/2 3 meters per second squared times our new time, 5.63 seconds squared, and we get a new position, 47.5 meters. So then again, that's at 5.63 seconds. Okay. So again, this is when we catch the Porsche, and that's when the Porsche catches us. Okay. Right, so we got one more part for this problem. It says if a police officer happens to catch us and the Porsche and a radar gun at the instant the Porsche passes us, will either one of us get pulled over for speeding? And we're going to say the speed limit is 50 kilometers per hour. Well, we already know that, so the speed limit's 50 kilometers per hour. We'll write that down. Well, the original problem, we know that we're moving at 11.11 meters per second, or about 40 kilometers per hour. And we know that we never change speeds. So acceleration is always 0. So when the police catches us, we're still going to be going at 40 kilometers an hour, which is 10 miles or kilometers an hour under the speed limit. So we'll be fine. We just have to figure out if the Porsche is going to get pulled over. So we'll go back to the Porsche, and we need to figure out the velocity of the Porsche after 5.63 seconds. Well, velocity equals acceleration times time, in this case, because we don't have an initial velocity. So we just plug those in. We know our acceleration is 3 meters per second squared, and it has been 5.63 seconds, because that was our time for when we caught up to each other. We do that, that's 16.9 meters per second, but again, we know that the speed is in kilometers per hour, so we're going to have to do a little bit of conversion. So we're going to multiply that by 1 kilometer over 1,000 meters, so that our meters and our meters cancel out. And then we also know that there's 3,600 seconds in 1 hour. Now you notice I put the seconds on the top because over here the seconds are on the bottom to cancel out. So we're going to be left with the kilometers per hour. And if we do that, that's 60.8 kilometers per hour, which is a good 10.8 kilometers an hour over the speed limit. There's a pretty good chance he's going to get pulled over.